Now in this tutorial, we're going to be working on an example where we're going to have to change the base of a logarithm in order to find its value. And so let's go ahead and solve this example using the rule that we have discussed, log b with base of a is equal to the reciprocal. Now solve the equation log x with base 5 plus 6 log 5 with base x equal to 5. Now, the first thing that you can notice is that we do not have the same base. The first logarithm has base 5, but the second one has base x. And so what's going to happen is that we're going to have to switch the base over here so that it would become 6 log x base 5 so that both logarithms will have base 5. Log x base 5 plus 6 log 5 base x is equal to 5. Let's go ahead and try and change this one right here so that it would have the same base as the first logarithm, and that would definitely make our work much easier. Moving on, we're going to use the rule that we have discussed previously, and we say but logarithm 5 base x is equal to the reciprocal, and in the denominator we're going to switch. So we're going to have 1 over log x base 5, and this is the reciprocal of log 5 base x. Notice that now we have the same denominator and the same base. So log x base 5 plus 6 into 1 over log x base 5 minus 5 equal to 0. We subtracted 5 from both sides of the equal. Let y be equal to log x base 5. So the new equation is y plus 6 over y is equal to minus 5. Now multiply y. And so we're going to have y into y plus y into 6 over y minus 5 equal to 0. And of course, here we have introduced y in order to get rid of y in the denominator. So it's going to be y squared plus 6 minus 5y equal to 0. Let us change the order of this, of course, since that would be y squared minus 5y plus 6 equal to 0. This is definitely a quadratic equation. And whenever we have quadratic equation, we tend to find the discriminant. And so in such case, it is b squared minus 4ac. Of course, a is equal to 1, b is equal to minus 5, and c is equal to plus 6. And so that would be 25 minus 4 into 1 times 6, which is 25 minus 4 times 6, which is 24. So the answer was 1. The square root is also 1. So y is equal to minus b minus square root of discriminant over 2a. This is y1, which is plus 5 minus 1 divided by 2, which is 4 over 2, which is 2. Or the second one, minus b plus the square root of discriminant over 2a, which in such case is plus 5 plus 1 over 2. That is 6 divided by 2, which is 3. So here we have these two values, 2 and 3. And still, of course, we are not done, since we still need to find the initial value. What we have found out right now is the value of the discriminant and the value of the roots. But y equal to log x base 5. And so if y is equal to 2, then log x base 5 is equal to 2. Or if y is equal to 3, then log x base 5 is equal to 3. We are not done yet. Here, it's going to be 5 squared equal to x, which implies that x is equal to 25. Or 5 cubed is equal to x, which implies that x is equal to 125. Both values are, of course, possible for both.